So in this video we're going to run through excuse me, how you actually go about calculating standard deviation. We've looked at why it's useful to calculate the standard deviation for a data set. So this is actually how you go about doing it. The context in this example is looking at two groups of people. It's just a small sample size, it's just 5 people each. 2 groups of people where their heart rate is measured after using a treadmill. One group is those who exercise regularly and those who don't exercise regularly. Just before we start with standard deviation, I thought this is just a good opportunity just to remind ourselves about how you can summarise data sets in terms of their averages. We talked about means, modes and medians. What I'd advise you do, because you might be asked to do this, is take the data set and then actually write it out from in ascending or descending order, it doesn't matter really. So if we take the exercise regularly group, if we write it out in ascending order, we would have 82 and then 86, 87 and then 90 and 94. If you calculate the mean for this particular data set, and the mean is 87.8, so you add up each of the individual values and in this case divide by 5. The median is the middle value, so in this case 87 is the median value, and in this instance there is no mode because you don't have a most frequently placed value. Let's say that we had 82, 87, 87, 90, 94, in which case then 87 would be the mode. Anyway, that's just a reminder of those 3. So let's look at the standard deviation equation. Remember, standard deviation is showing you the spread of the data around the mean. So S stands for the standard deviation, and effectively what you're going to do is for each of the values in the data set, so X represents each value, you are going to subtract the mean, so the mean is X bar, you're going to subtract the mean away from each of those values. Then we're going to square it because we don't want any negative values. And then you add all of those up together, so sigma is the sum total of. And then you're going to divide that value by the number of values in the data set minus 1. So that's the idea in terms of looking at the spread of the data around the mean. I always lay out the equation in a sort of tabular form, just so that you can look at carrying out each step, just makes sense to me. So part of it's already done just to speed up the whole process. I'll work through the exercise regularly group so you can see what we're doing. Then if you have a go at using the same sort of same table, doesn't exercise regularly, we'll look at the answers and then we'll draw conclusions and we can see what's what. Okay, exercise regularly. Initially then you write out each of the different values. I always do this underneath, I then just write down what the n value is, so in this case it's 5 and therefore n minus 1 is going to be 4. We've already calculated the mean value, which is 87.8, and then you're just going to go about carrying out the whole process. So I'll start to work through it. As soon as you get bored, just fast forward towards to the end, see check you got the right answer. Okay, so we're just going to start subtracting the mean away from each of the values. So that's x minus x bar, or the value subtracting away the mean, and then we need to square each of those just to get rid of any of the negative values. So hopefully that's all right. Then we need to, so that's the process we've carried out there. Now we need to find the sum total of all of those values, and that should be 80.8. Excuse me. Then we're going to divide 80.8 by n minus 1, which is 4. So 80.8. And that should give us 20.2. Then you're going to square root 20.2. So square root that, and hopefully we all get 4.49. So as we said previously, we know that the mean is 87.8 beats per minute. And so if you go one standard deviation above, so we're adding 4.49, and if you go one standard deviation below 87.8, 4.49, as we said previously, that should account for 68% of the values in the data set. Really, we can't go to 2 standard deviations because we simply don't have a large enough data set. It does need to be bigger. So to summarise, we've got, for those who've exercised regularly, their heart rate after using the treadmill, we've got a mean of 87.8 beats per minute, and we've got a standard deviation of 4.49 beats per minute. So if you have a go at doesn't exercise regularly, and then we'll have a look at the answers, so you can pause and then check. So just to save a bit of time, there's the calculations for the second data set. Doesn't exercise regularly. Hopefully you have calculated a mean of 104 beats per minute. You then run through all of the steps, and you get a standard deviation of 9.11 beats per minute. So here you've got a mean of 104 beats per minute. If you go one standard deviation above, so you're now adding 9.11 beats per minute. If you go one standard deviation below the mean of 104, that's what we should get. What conclusions can we draw from the 2 data sets? Really, the sorts of things that you should be doing here when we're drawing conclusions. Comment on the 2 mean values, because you've got to calculate the mean when you're looking at standard deviation. Comment on the size of standard deviation and try and make a link there to reliability again. So in this case we could say that with the does exercise regularly group, it has a lower mean value, or they have a lower mean value of 87.8 beats per minute compared to 104 beats per minute. And in this instance we can also see that there's a much smaller standard deviation in the data for the exercises regularly group. There's a larger standard deviation for the doesn't. We could infer then that the reliability from the does exercise regularly group is higher, smaller standard deviation, higher reliability, and for the doesn't exercise regularly group we have a larger standard deviation and therefore the reliability is lower.